Okay, let's get started. It's 10 o'clock. Good morning, everyone. Morning. Morning. Hello, good morning, everyone. There are 18 other people. All right. Let's get started with our slides. This week is Unit 6, and we'll be talking about reliability. Thank you. Wow, summer. It's just this week that it is warm. Next week is 13 degrees. But you can enjoy your summer dressing. Okay, so this week we're focusing on reliability and validity and we did instruments, right? So what I do the housekeeping, which is your attendance and make your announcements. I'd like you to go back and do a quick revision about what did we do last week. I'm going to ask you guys to tell me what did we do last week. And I will take your attendance. How was the weekend, by the way? Good. Thank you, Simpson. I met you guys on weekend. Anybody else? There are 20 people here. How was the weekend? Thank you. Thank you for telling me the secret. Okay. It's 25. Okay. Celia, Giselle, Cherry, Ishan, Yana, Zoe, Paula, Cecilia. Celia and Cecilia sitting next to each other. Jacqueline, Simpson, Snow, Jason, Joyce, Esther, Susan, and Zoe, Rosalind, White. White, I'll not forget you. You will see today. Vicky? Oh, Vicky there. Okay, thank you very much. So I've got few important things to remind you all. And let's get started. We are going to spend a few minutes talking about what's coming next. So in our last class, we spoke about levels of measurement. Yeah, remember? I'll talk about that. And we talked about interval scale that all of you, most of you would use interval scale and nominal data. Remember? This week means on Tuesday and Thursday, we will talk about, don't read other things. Just pay attention to what I'm saying. I can see your face. This week we'll talk about, in today's class, we'll talk about reliability and validity, which is very important. When you conduct your experiment for this class, I'd like you to check reliability. Validity, maybe you can do all, but you can do some. Reliability is easy. I'm going to show you in SPSS once again today, if you did not learn it in your PS5 3 development class. And next Tuesday, Thursday, I'm going to talk about sampling, and let's see, have organized a small activity, right? So we'll talk about sampling, and at the end of next class, I'm going to give you a template about how to write sampling. Okay, we'll talk about that next week. Sampling for experimental design would look a little different from sampling in survey designs. So we'll talk about that, and I'm going to give you a sampling template. And This weekend is a big weekend for you. There are a lot of things that you have to do. Number one, you're going to put together your instruments details and your sampling details together using the tag. Okay? Get me? Okay. Now you have to add that new write-up with your introduction write-up, the one that you submitted 2 weeks ago. Got that? So what does it mean? It means the revisions on your introduction slide, introduction draft needs to be addressed. And if you remember, what did I say? I said, do not delete my comments. So don't delete my comments. Either turn on track changes or highlight in red. Okay. Ishan, no, Esther, you deleted everything. Don't delete. Leave my comments on and make changes so that I can see what revisions you're doing. Okay? So now I repeat, do not send me 2 documents. Send me a single document that has your introduction and that also has your sampling and instrument. Is that okay? So this is your weekend task. What time is it due? It's due next Monday at 12. Yes, everyone? Is the next cloud disturbing you with sound? Is it too loud? Is that okay? Too loud. Okay, so this is clear, right? So this is your weekend job. Now, once you run the task, is next week. We've got entire this week and a weekend. Next week, I'll see you on Tuesday. What are we doing on Tuesday? We will have a lab visit on next Tuesday, right? We'll be going to psychology lab and you will learn how to use VR glasses and eye tracking. Okay? Somebody would come and give you demonstration and then we can think how we can integrate those tools in your technical study. Okay, next week, Tuesday, we're also going to have a pilot testing of your skill. So what does that mean, pilot testing of your skill? We cannot do a real pilot. You know what pilot? Pilot is, I'm not talking about the one that flies plane. Simpson, can you translate that in Chinese? Just pilot, right? What's that? Wrong. Well, that's pilot testing, and we cannot do in real. I mean, in real life, you should have at least 50 to 100 samples, read your scales, and say, oh, this item doesn't look good. Remember, we talked about how to write your items. You develop your skill. Double barrel, loaded, double negatives, all of that, right? So pilot testing needs to, in real, it is done with 100 to 50 to 100 participants, and then you look at reliability and you look at other statistics to determine if your scale is working well. But we can do that. It's a mock research class. So what are you going to do? Each one of you is going to bring um, four printed copies of your scale, each one. And then we will have a free go. Everybody, you will have to find 4 people who will read and give feedback on your skill. Okay? So it's a good idea to find your 4 participants. You can say like, I'll read yours, you read mine. So each of you will get feedback from 4 participants about how clear are these items. Or did you think it was too long questionnaire? Do you recommend some items are similar, overlap? So I will train you next Tuesday about how to go about doing pilot. Okay, and we are also going to have revision. So, your quiz is going to be like 30 minutes, right? You will have 40 objective type questions. Joyce is like, Joyce, if you do not attend my class, you will like, what is Nikki talking about? Everybody else who has attended my class, you know what my quizzes are. They are objective type quizzes, okay? So objective types, match the following. I don't have fill in the blanks. So most are true and false, objective, match the following. So I am going to have 40 to maybe 35 to 40 or 45 around this. Simple questions from the units that we have covered. Next week, I think I will do the revision before the quiz. Quiz will take 30 minutes perhaps. So this is for next Thursday. We begin our class with the revision. Okay, our lives with you, and you guys do your quiz. Those who did not take any class that week, please download our make sure you log in nicely and it should work. Okay, not come and say, oh, Professor, I forgot my password and I cannot log in. Once the quiz is done, we're going to go. This is your midterm quiz, by the way. You will continue the right paper presentation. So who's presenting this week? You. So, and who will present next Thursday? Next Thursday. Okay. So after quiz, we will have your presentation. Is that okay, everyone? No. Any questions? You can talk to your friends and discuss if you have any questions. No questions? Sorry, why? No? Okay. In quiz, 40 or maybe 45. True and false. Choose which type of sampling. Not. Yes, I will do the review for the quiz. Or you want me to do the revision on Tuesday? We can do either. Tuesday? Okay, great. So, Leslie, I've given you the revision slides, right? Yeah, so we can add some more. So let's have revision on Tuesday and lab visit. Okay? We can do the quiz and we can do the pilot and we can do the oh, that's a good idea. So what you guys can do is give your friends, your participants, the pilot scale and tell them to speak, repeat, and write comments for you. No worries. Okay? That's it. That's wonderful. I like this idea. Okay, no one will see. If you ask questions, you're helping yourself. Are there any other questions? Yes. Okay. That's a very good question. Now, there are two things. One is your experimental procedure, your intervention. So do not confuse with your measurement and your instrument. The video that people are going to watch is your intervention. We are going to do that intervention later in, I guess, week 10 or 12. So right now, when they watch, you will have them watch a video and they will have to answer based on that video, right? So I completely understand that video is important. You can maybe give a link to people if they, but the thing is, tell them, assume that you watched that video and read these items, or you have any task. Some of you have a task to do, right? Bring your task and instructions. I know Jacqueline wants to do creativity task. So bring your instructions and see how people will do that. The idea is your measurement is central to your data collection measurement tool. And that measurement tool has to be perfect. Otherwise, you're going to have problems. And in today's class, that's what we are going to talk about. We are going to talk about issues that you can have if your scales are not designed or articulated properly. Okay? Now, before I move to that, this is just an overview. I have given you the template, right? You're going to make sure when you do your write-up for the draft, you have all these components in your draft. Who developed the scale, how many items, what is the Likert scale, give an example of an item, and reliability from the past studies and reliability of your study. You're going to ask, Professor, we don't have a data. Yes, I know. Leave blank. The reliability for this instrument for this study was blank. Once you have the data, you will calculate the reliability and you can go and fill in. Okay, so the learning outcomes for today's session are, we will be talking about measurement error, observed score, and true score. And the most important thing we are going to cover today is, if most people have an idea what is reliability and validity, we'll talk about different types of reliability and validity. You guys are going to calculate Cronbach alpha, internal consistency reliability. I hope we have enough time and I can show you how to calculate that reliability. Let's get started. See, White, I told you that I will not forget you anymore. Okay, so we know that White is smart in study. He's a brilliant student. We know that, right? Yeah? Yes? Okay. He shocked us when he received only 50% in midterm. Yeah. What do you think happened? Is 50% a true score? Does that score reflect White's real intelligence? You know that what happened? Any idea? I want answers. If not, I will not move forward. White, you can defend yourself. Excellent. It's not White's intellect that you can question. Maybe the test paper was very difficult. What else? This is one of the factors. What else could be an explanation of this performance? Awesome. The contents, even though the test was easy, but the contents were out of something that we did not study in the class. So you know what? You guys are giving me signs. Nitki, midterm should not be difficult. Nikki, midterm should not have anything that we did not study in this class. Excellent. What else? Something to help you guys now for midterms. What else? Come on, quick. The wonderful answer. It is not for me to make a good midterm, but it's also for you that maybe White did not sleep well. His memory is a why did he sleep well? Could be hundreds of reasons. Maybe he had too much homework, he ate something that was allergic, or maybe what else do you think? One more? Like, the fire, you could hear the stress. So the idea is, whenever we try to measure something, it is very rare we get the real score. Okay, there is always background noise. Okay, there's always background noise that's going to affect someone's true score, right? So what's a true score is basically a a true value given for something which is almost impossible to catch. Remember we talked about in the beginning, we want psychology to act as science. We want to research like scientists. We want to be objective. When you want to measure someone's motivation, it is a very common construct in psychology. Motivation is not something that you can measure. Wow, this is like 100 ml or 200 ml. It's a state of mind, and it is very difficult for psychologists or social science researchers to measure something accurately. There is so much noise going on in the background. So our idea is we always want to capture true score. But the one that I got on the exam, the 50%, is not White's true score. That is called observed score. Got that? Observed means something that teacher or you, we as researcher can capture. That's observed score. What is observed score made up of? You can see here. What is it made up of? Louder, please. A true ability, White's intelligence, but also it has something attached to it, which is called random. We also call that random error as measurement. Right? In the measuring, you can have error. Right? So the difference between true score and measured score is equals to measured error. So that equation could be solved. You know, you're good at math. Everyone is good at math. So observed score, if you take out the true score, this is your measurement. Okay? Now we are more concerned as scientists, our objective is to measure a score which is as close as possible to true score. And I want to repeat, it is not easy for us capture true score from anything. It's motivation, intelligence, Japanese spoke to me, creativity, self-determined motivation. You want to capture the score from your participant. Is it possible? Not really. But as scientists, we can do our best to avoid that measurement error. Okay, so can we measure the true score? Now let's see. Thermometers can measure true temperature. Do you agree? A weighing scale can measure true weight. A ruler can measure true length. How many of you agree with these statements? Put your hand up. Or if you have questions, or if you do not agree. I will wait for your answers, not the same faces. Other people, I'd like to hear your voices. What do you think? Take a moment and think. Do you think thermometers, weighing scales, and ruler can measure true score? Yes. Rosalind says yes. Thermometer, we were talking about our ability to capture true score. But Rosalind said yes, thermometer can give us the temperature. Weighing scale can give us true weight. That's a true, there's no error in it. That's a true score. Does everyone agree with Rosalind? Ishan, why do you think so? There are numbers after the point. Okay. Continuous number, maybe it's not that perfect because there are 4 decimals, right? So according to Ishan, maybe it's not a perfect score, not still a true score. There is still some error. How many of you agree with what Ishan said? You agree? Anybody else? Everyone agree? Wow. Rosalind, would you like to say? Thank you very much. Thank you, Ishan. Yes, there could be an error in the measurement tool, right? Weighing scale, have you seen my house has 2 weighing scales. And every time I say, oh, wow, if I set another, I have some of you experience. So even these physical instruments are not able to give us correct information, right? That's why doctors would use thermometers. Because each thermometer has a little different measuring the true score. Look at that. Our survey scales are not even physical instruments. The scale that you are going to use, the pilot, is it a scale? Is it an instrument? No. It's very psychological, very subjective. So it is very difficult for you to measure something. You want to measure someone's happiness, someone's anxiety, using the scale, not a thermometer, not a weight scale, not a ruler, but that report questionnaire. Imagine the amount of error we bring to our measurements. Okay, so what do we do? Our job is to control that error to get the true score. We are going to use statistical measures to make sure we control our observed score has a very little error so that we can get to the true score. Together? So how can we do that statistically? Okay, before we move on to that, remember you guys gave me lots of responses about hypothetical scenario where White received very low score on his midterm. He said it could be the difficult test, it could be White himself, it could be noisy classroom while taking the test. So we're not getting so much into detail. I guess you studied about measurement error and the factors that contribute these errors in test and measurement class 4200, right? There are so many sources of these errors. Now, one of the sources that we are concerned here is instrument loss. If your scale is flawed, you're going to be in trouble. So those who will be doing your capstone project, okay, one student just before this class came up to me and she has very different idea about her capstone project. I said, you can go ahead with doing anything that you wish you would like to do for your capstone, but the responsibility is yours in terms of how much data you can bring. You think your data will be a good data. If you're ready to bear that, go ahead. I will not push you to just do the survey study. If you want to do experimental designs, go ahead. But you should be sure, because if your data doesn't look good, or it's not enough, or, I mean, you say, Professor, I've got 15 samples. You cannot do your capstone with 15 samples, right? So you need to make sure your data is good. So one way you can make sure your data is good is through having a reliable. So reliability can be affected by so many things, which is instrumental flaws, like a faulty thermometer. We were talking about that. The physical instrument is broken. Environmental factors, we spoke about that, noise, observers, inconsistency. I will talk about that a little bit when we discuss interrater reliability. Human beings are subjective beings. You want to measure people's happiness. You go to one class and say, hey, can I measure your happiness along with other variables? Maybe something is happening in that class which is making students unhappy. So it's not your IV that's causing that unhappiness. There is something else that's happening. There are other systematic issues that can affect validity of your instrument. Could be calibration issues, cultural bias, some kind of, this is Hawthorne effect. We will talk about it in detail when we talk about threats. Okay? And ambiguous questions, teachers scoring key wasn't good, and other mistakes. Now, these are different sources. We are not talking much, but we are talking more. We are focusing more here about the reliability of your instrument, questionnaires, scales that you will be using for your experiment. and that you will be using for capstone data. Okay, so what is the relationship between error that we've been talking about and reliability? A highly reliable test or instrument or scale will have very little measurement. Of course, right? It's not just the scale, it's the way you collect your data. It will also contribute to reliability. We focus right now here higher on reliability. Higher reliability equals small measurement error and better estimation of true score. Okay. Done research and technology. You've been 4230, you've done PSY 3200, you've done PSY 4200. Everyone knows what reliability. Yes? Okay. Can I hear an example? Read this. What do you understand by this? Can I have an example? You want a GPT? You want to Google? No. Just think. It's okay to give wrong answers. What do you understand by this? Reliability refers to consistency or stability of measure. Measure, remember, we talked about measure, instruments, scales, questionnaires. What does it mean, consistency? Any idea? Wrong answer. Welcome. I know some of you know the answers. Please come on, don't be quiet. Great. If two people take one measurement, we expect the same results. For example, I have two wonderful people who chose to sit right in front, Simpson and Giselle. I assume both of them have high motivation. If I give them a motivation scale, the findings should be very close, not exactly the same, maybe, but close, right? So what does that mean? It's the same for Simpson and it's the same for Giselle. That's called consistency. Then you think, this is just basic definition of reliability. We will talk about different types of reliability in a moment, and you will understand how do we measure reliability. So reliable measures means reliable scales of psychological variables like intelligence will give the same result each time you administer the test to the same person. Now, let's take example of white. So I had a questionnaire and I gave it to White and I said, White got 50%, remember, in my midterm. And then I would think almost the same difficulty level questionnaire test paper and give it to White. Expect White to get again the rate. If White gets 80% in like 2 days gap or 3 days gap, or maybe the same day, the distance difference between time 1 and time 2 is large. Who is, like, who should I question? Is it White or is my test paper? Should I question? If I gave White a test, he got 50%. Maybe in 2 days, he didn't do anything. I gave him another test, which is very similar to the first test. And this time he gets 80% or 90%. Who should we question? The test, maybe, not White. In 2 days, it is highly unlikely that White became so intelligent without doing anything, right? It must be the test. I'm saying these are two same tests, but in reality, no, If this test was too difficult and this is easy, right? Unless White got enlightenment from the environment, he became super intellectual to answer those questions. White, you will do wonderful. These are just examples, okay? Don't get scared. So this is what. So if you do the test again and again, now the test will be unreliable if measure the same person 1 week low the next and right week next. Is the example that we just talked about. Okay. So to put simply, this is how it is. A reliable measure will have greater, unreliable measure will have greater variability. Look at this. In PS5 3200, we talked about variability, right? If I use a scale, sometimes my students get 85, and sometimes they get 100, sometimes they get 115 on the same scale. Thing is wrong with the scale, isn't it? But if I did the test again and again, the reliability, the score fluctuates, but it doesn't fluctuate that much. It fluctuates with 90, 100, 95. Got that? So which is more reliable? The one with narrow variability is more reliable. Now, reliability can be tested. There are 4 types of reliabilities, and you can apply different methods to measure reliability. Okay. So what I'm going to do now is I will shut up for like 2 or 3 minutes. I will put a timer. I want you to read 1, 2, 3, 4 with the person sitting next to you, right? And then I'm going to ask volunteers to tell me what you understand with one example. Okay? How are we going to do this? Is one, here 1, 2, we'll do number 2, 3, 4, 1, 2, 3, both of you, 4, 1, 2, 3. I'll put the timer 3 minutes. 3 minutes, and don't forget your. Let's see, can participate if you want, but you can just walk around. Okay? 1, 2, 3, 4. 1, 2, 3, 4. I said, you're what number were you? You're with her? Okay. You do number 1, number 2, or number 3. Or who's did I say number 1? 1, 2, 3. Okay. The 3 minutes timer. What is it? Give me an example. Okay? Give me an example. One minute, 40 seconds. Explain and give an example. while having a good discussion with ChatGPT or with your friend. Be ready. Who's going to speak? 40 seconds left. Ten seconds. 5 seconds. Okay, time's up. All right. Let's start. Number 1? No. Exactly number 4. How many people got to read number 4? Inter-rater reliability. Put your hands up. You there? 1, 2, 3, 4, 5. Okay. Who would go first? Explaining. Not White, I guess. Jason or Zoe? Can I give them a chance and then I'll come back? Okay. Because you always answer. Okay. That's not worry about your turn. Can you? Can you just do this? Do with your computer screen so that we can have a discussion. Okay? I think it's a wonderful explanation and it's very easy to understand. Okay? The different people will give grade and then you have to see how consistent. Remember, reliability is about consistency. How consistent people are about that particular evaluation of that particular thing. Thank you, Zoe. It was a good answer. You guys have your phones with you, right? So what I'd like you to do, put your screen, don't turn off your laptop, I know that, but put them down so that you're not reading. So let's do one real life example of inter-rater reliability. You don't have to turn it off. I did not mean that. I said just hold it so that you're not looking into like Jason has done that. Okay. Now let's do a real one. Inter-rater reliability here. XXX is my bottle. You can see my bottle. I'd like you guys, all of you, to have a look at my bottle and evaluate it based on these 3 criteria. Period. Is it good looking? If you say not at all, don't worry, I'll not be mad, okay? And very much, give 7. If you think so, give 4 or 5, okay? Is it very useful? 1 or 2, 7? Right. Now what you have to do is add up your score and send me here. Did we not take my bottle? Do you think you will hurt me? I'm your teacher. Let's take this bottle. Okay. No, let's take this block. Doesn't belong to anyone. Okay? XXX means this block. I do not want bias answers. They have to say something, but it may not be very useful. Okay. I'd like you guys to give me a score. Now don't forget, it's on a scale of 1 to 7. Okay? If you really like everything about this, your maximum score will be 21, right? So send me your answers on WeChat like this. 8 on 21, 9 on 21, something like that. Okay? We are trying to find your measurement of this cloud. I'm going to check your responses here. Did you send already? Just your complete score. That's it. Complete score. This is how scoring will be done for your scale. I'd like to see complete score. We are measuring, we are assessing the appearance, use, and valid price. Let's call this a construct, right? These are observed attributes, right? The construct is selling capacity of this clock, for example, right? A construct. We have conceptualized a construct. How sellable this clock is. And we're going to measure this with these three observed, remember we did that? Observed variables. And these variables are measured on an interval scale. And I am waiting for answers. Awesome. Thank you very much. Perfect. Thank you for sentence. So, our range varies from, I guess, 10 is the lowest and 19 is the height. Okay? Together? So, 19, Vicky, you're very kind to like this. So 19 is like an outlier because nobody is close to Joyce. You're also very kind to give it 17. Even Jason, 16. Very kind people and very kind to this. Okay. Now, you can see the range maximum people. You can count. We are trying to establish inter-rater reliability, right? How many people have said 10? 1, 2, 3, 4. I'm not reading your names, right? 4 people have said even 10. How many? 12? 1, 2, 3, 4, 10 to 12, right? 4 people have done 12. Got that? Not. Got that? How many evaluators did I have in my research? Not everybody has sent here, but let's say 20. What are you going to do? You're going to put those 20 into how many 10s, how many 11s, how many 12s? Okay? Is there any correlation between these numbers? Okay? We will make it eyes without doing any calculation of interracial reliability. You can just say, you are measuring it 10 to 12. What would be our result of this study of iterative reliability? That this clock does not have a very high sellable attribute, except a few people who really love it, red color and white color, right? But most people agree between 10 to. Now there is a statistical method to calculate correlation between different evaluators, which I will tell you maybe towards the end when some of you might use inter-rater reliability to measure certain things. Like, I think, Jacqueline, you are looking at the creativity task, fluency, right? Fluency, if you're measuring creativity by doing that, fluency is one of the components which you measure through inter-rater reliability. Right? You will have a person, oh, even creativity, somebody has drawn something. You're going to have 4 to 5 assessors look at that value and tell you how do they feel about creativity? Because creativity isn't, right? So some of you who are doing something to do with creativity and task would use inter-rater reliability. So when you're measuring it, you have to make sure 5 people feel the same. If they don't, either you need to appoint more assessors or you will make a conclusion. For my experiment, I can make a conclusion looking at 8 values between 10 to 12 means it's not very high on sale. Right? You get that, everybody? Right? If this was a little complex, think about inter-rater reliability in terms of your daily life. Your friend comes and says, hey, I went to Big C and the restaurant I ate was wonderful, so delicious. I will give 10 out of 10. You're like, I want to go and eat there. But this person is so kind, like Joyce. She gives 10 out of 10 to every restaurant. I'd like to ask somebody else who's both critical about food. How much would you give? And that person said 8, right? Good. Let me ask somebody else. That person gives 9. You kind of have an agreement with people is what happens, right? So you are establishing your inter-rater reliability before you make up your mind and you decide to go and eat in that restaurant. Is everyone clear with the inter-rater reliability? Right? Some of you would definitely use it when you do creativity assessment. Okay? Let's talk about number 3. Who are, put your hand up. 1, 2, 3. 3, 3, 3. That's it. You also did. Okay, Shen, you've given a lot of answers. Let's start with Sherry, Cecilia, and Celia. Cecilia and Celia. What is internal consistency? Guys, pay attention. This is one of the most important form of reliability, which many of you will use. Internal consistency reliability. What do you understand by your discussion?
It may measure all questions in a score, whether measure the same concept.
Okay. Um, if the questions measure the same concept, well, this is also a good definition of validity. If the questions are measuring what they're supposed to measure, but I know that you understand, but you're struggling a little bit with the articulation. Yeah. I mean, you're there. Cherry, would you like to try? A little louder, please.
Maybe the each item in the survey, their answer should be.
If you're taking a survey, your answers need to be consistent. This is called internal consistency reliability. 99% of you who are using scales will have to calculate internal consistency reliability. I'm not saying the answer is wrong, it's a good try, but it's very close to definition of validity. What Sherry explained is, yes, you're talking about school engagement. Your answers should be consistent. Okay, let's take an example. Thank you, Cherry and Celia and Cecilia. Let's look at that. Okay, to try and understand internal consistency reliability. I like my school. Okay, let's say this is an engagement scale. Okay, school engagement scale. Let's assume Giselle and Simpson, because they're sitting right in front of me, I'm looking at them. Okay, you both are very motivated students. Very good. That's why you're sitting right in front. Everybody else chose to sit at the back. I like my school. Simpson and Giselle, both of you, 7. Yes? Oh. I enjoy going to school every day. 7. Yes? I school is fun. 7. 7. I remain absent 50% of the time. 7 or 1? 1. Yeah? Don't forget reverse item. Yeah? I love my teachers. 7 or 1? My teachers are terrible. Now listen, they are going to say 1, of course, because they are very engaged. What if both of them gave 7 here and gave 7 here? Or maybe gave 4 or 6. You get that? And you're going to look at the responses and you will be like, you love your school. You are saying you love to go to school every day, but here you're saying you miss your classes 50% of the time. Now, is it possible for a researcher to check each response by person? If you get data from 500 participants, are you going to go and check? Let's say this item, and this is right opposite. This is right opposite. So if person takes 7, expect 1 year, right? To be the real measurement, right? What if, are you going to check for everybody if this is 7 and 1 or 6 and 2? No, we can't, right? If you have so many people. I have some research projects where I have 3,000 data there. So you cannot check all of that. How do you check that? How do you check? The people are consistent in their response, like Cherry mentioned. If you say you love going to school, we expect you will be saying 1 year, not 4, not 6, not 5. If you say you love your teachers, we expect you're going to say 1 year or 2 maybe, right? But not 6, certainly, not 7. How do we check that people are inconsistent in their response? What do you do? Any idea, everybody? Quick, quick. Any idea? I'm waiting for your answers. Think. What do we do to, oops. Oh, no, 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 no. What did I do? Oh my God. What do we do? Any ideas? I'm sorry. No signal. I didn't mean to do this. Okay, there. No idea? Yes? Outliers? Maybe, yes. Any other try? You would reverse? Well, I love my teachers, 7. My teachers are terrible. This person is giving, I mean, 1, not at all. He's giving 4. He loves his teacher, but he thinks his teachers are terrible. Reversing is helping when, there are exactly you believe are reverse responses. Okay? Okay, these items are polarized. Let's say this. I like my school. 6. I enjoy going to school every day. You think something is happening. This person is not consistent with what he's saying. Right? I love to be fit. 7. I eat a lot of sugar. Alright? Okay? So these are inconsistencies. How do you measure that? First thing is you cannot check by hand. You need to use a statistical method. Okay? What's the statistical method that you are all going to use is calculate reliability, right? And that reliability tells you what is the movement of participant response, right? In there, you might feel that one item is acting weird, and then you go back to your scale and see why is this item acting weird? Do I need to reverse it? Sometimes you don't have to reverse. These are both positive items, but you still see this item is acting awkward. And this is where you know your scale is not perfect. There is something. Okay? So what I'm going to do, you can also turn on your laptops if you have an SPSS file. Let me take you to an example of, let's say, my friend and I are conducting this research. This is a cell regulation questionnaire. Let's check its reliability. If you guys have SPSS, any data, feel free to open it because this is what you all are going to be doing. Now let's go here and check here. Now look, this is a self-regulation questionnaire. How many items do I have here? I have so many actually. Let's quickly check. Okay. Oh, so these are different items. I've got SM 13, DL 14 to 25, and CS 20. I'm interested in checking these 13 items. What's the reliability? 13 items. Pay attention. Go to Analyze, go to Scales, and click on Reliability. And I'm recording this class and I can give you the link so you don't have to worry about taking notes. So select, press Shift, select until 13 because 14 is DLSD, which is not an item of the scale. Bring everything in here, okay? Go to statistics. We did that before in case some of you were not in my class. I'm repeating it. Click on these two. Look, scale reliability. How consistent are people's response, whatever the items are? Now, if the reliability is poor, this box is going to tell you which item, if you delete, the reliability will increase or decrease. So you need to click here for more information about about the items, if they're acting the way they should, they are expected to act. Okay. Wow. So 0.86 above 0.6065 is considered good. Anything above 80, 90 is perfect, right? You can never have one. One is a perfect and correlation. How many items do I have? 13. This is a good reliability. But can I have like 89, 87? Yes, I can. Look here. Look. 87. What does it mean? If I delete this item, I can increase my reliability to 80. Okay? Now, those who did PS53200, you understand correlation. So what is it doing? Looking at all the items are correlated, if they're all going in the same direction. It's looking at the consistency. Maybe one item is not following the trend with the other items, it will be caught in here. Get that? Everybody okay? So, yeah, I think only if I remove this item 3, let's remove it. And we will say our reliability increases to 8.77. Oh, what item was that? Item 3, okay? No, I will go back, analyze, scale, reliability, item 3, was that? Okay. And I press OK, 8.77. Now look, it says if you delete number 1, it could further be improved to 0.89. Okay? Now you don't have to go on deleting because if you delete items, then you are not measuring the construct which we will talk in validity. So this is the overall idea. Cronbach alpha, internal consistency reliability, is the one that you're all going to check. Super simple. Analyze, scale, reliability, bring all the items. So once you've done your pilot with 4 people, it's not really possible, but if you can do it with more, you can check internal consistency reliability. Okay. I will stop it and I'll give you 1 minute to think and talk and ask me a question about internal consistency reliability because 99% of you are going to run this for your experiment or for the data that you, for the instrument that you will use to run your experiments. So go ahead and ask questions. No questions? Everybody? Please discuss among yourselves. No questions? Okay, great. Let's move forward. Okay, let's get back to where are they here? Who was number one? Which group was number one? Simpson is so excited. Number one? Okay, it's very simple, but that's simple. Okay, what's that? Same test twice. Yeah? Would you like to add something to anything? Maybe three times and four times. Okay. Does anyone see any weaknesses of test retest reliability? For example, a midterm exam, you do it, and I let you do it after 2 days, and then I let you do it 3 days. Do you think your score will fluctuate or it will be consistent? To be able, OET's midterm is very consistent. You're giving the same test again and again, right? Yeah. So test retest needs to be done with a lot of care. It means the time you give between test one and test two should be good enough for people to forget, okay, the content. Otherwise, they get. All right, number two, let's finish reliability and move on to validity. We still have time. Number two, Zal, Paula. That's it, two people. Okay. I will start with Giselle and then I'll come to you. Yes. Anything that you'd like to add? It sort of complements test reliability, right? So you won't have exactly the same, but of people, the frame between the time should be as small as possible. Okay. For example, I want to test motivation of these two people. I use self-determination theory motivation scale, and I see their motivation level is mean is 6. And I'm like, they don't look that motivated. This is too high. I will bring another motivation skill and give it to them. And I will measure it. I'm expecting if my skill is doing a good job, means if I measure motivation with something else, it would also be the same. Yeah? You guys are very young, so you might not be able to feel that, but when my son was young, my son was baby, he gets fever. I was like, you must have seen your mother, your cousin, kind of thing. And I was like, so I'll use different thermometers to check. Like duration reliability, but it's also equivalent form reliability. All the thermometers showing the same. It happens with you when you go and check your weight. Oh my God, I've lost weight. That's wonderful. But you want to check it again. The same scale to ensure there is a consistency. Yeah. So we are seeking reliability in our real life for so many things, but um, we should be able to check reliability of the scales that we are using. Is that okay, everyone? So for my part, I would not want you to do test, retest, equivalent. Each reliability is used for different purposes. When you develop a scale, you might want to do test, retest reliability to to see that your scale is working. Your scale is doing what it's supposed to. Your scale is working the way it should work all the time. Okay? But you guys are more concerned with internal consistency, reliability, and cronback alpha, right? Alpha, which I just showed you how to do. Is everyone okay with reliability? Yes? So please look for the reliability of the scale that you're going to use. And once you have the data, calculate your own reliability. If you think the reliability is not good, go back and check the items I showed you. This item is too long. This item is too complex. This item is not clear. There are so many ways. Either you fix it or you delete that item. Okay. Let's move on to validity. Okay. So I'm going to give you 1 minute, maybe 2 minutes to go through this. Talk to your friend. What do you think the scale is measuring? And let me know your answer. What is this scale measuring? Okay? Few seconds. You can talk to your friends if you want. 10 seconds. All right. Hands up. Who would like to tell me? What is this scale measuring? Okay, how many people would like to respond? Turn it up so I can pick your names. 1, 2, 3, 4, 5. No answers here? Ishan. Okay. I wanted to make sure that you all read. Okay. Rose. Measuring your ability to speak English, and it's also talking about friendship support. Anyone have any different answer? What is this scale measurement? What construct is it measuring? It's construct measuring about yourself. Anybody? Now I need more answers. Again, this is a construct about solving problems. Any more answers which are different? So many hands. Isha, what do you think? I think it's not measure one. I must say, thank you. Yeah, these items are not measuring one construct. These are measuring at least two or maybe more constructs. You get that? If you would give this as one scale, you will be so confused about what to make out of these responses. Got that? So, would you consider this as a good scale? No, you guys were so confused, and Ishan said this scale is measuring more than two construct or more than one construct. So, Cecilia and Celia, this is where your answer fits. What is validity? A scale, anything is valid. When you say it's valid, because validity means is the scale measuring what it is supposed to measure? Got that? The simple definition. Is the scale doing its job? What's the job of this bottle? To hold my water. If the water is leaking, or if I put water and it disappears, the bottle is invalid. It's not doing the job it is supposed to do. Okay? So scale's validity refers to the ability of the instrument measuring what it is supposed to measure or how truthfully it is measuring, right? This is why I highlighted here the operational definition of your variable should match with the items that you are going to use in your scale. Somebody had come to me to discuss their project, and just for example, I will not name. This person said, Professor, my construct is motivation. Okay, what motivation? School motivation. What's the operational definition? How motivated the student is to attend school and do the schoolwork and do well in school is the operational definition. Fine. Can I see the items? Guess what? The items were like, I'm very happy with my future planning. I enjoy interacting with my friends and talking about my future. The items have no alignment with the operational definition. Perhaps the items are measuring motivation to hang out with your friends, not motivation to study it. I had a very meaningful discussion with Jacqueline this morning during office hours. And I'd like to share with all of you for your capstone project and also for this class. When you decide which variable, and this is going to cause this, and this is going to cause this, always put the items. And you should be able to see a story. A story, yes, I mean it, a story. Your model should be a story with the items that you use. Let's say you want to say teacher autonomy support. Nikki, always ask if revision should be on Thursday or on Tuesday. Right? Teacher is autonomy supportive or not. What does it do? Let's say emotions. I feel happy. And let's say the outcome variable is motivation. I am always excited to study. These are the items, right? For motivation, one of the items is I'm always excited to study. For emotion, I feel happy, I feel stressed, I enjoy, whatever. Nikki always asks, when would you like to have quiz? Nikki allows us to choose the topic for our research, whatever. All these items should somehow be related, right? So this is the reason to ensure that your instrument, the scale that you're using is valid, the operational definition and the items should be related to the construct you're measuring, and this is called validity. Validity is a more complex concept, which I guess you might not be able to run it in your class project, capstone, maybe. Okay. Given the time limit, I don't think I can finish all types of validities, but I can at least finish the easier ones. So these are 1, 2. I made them in black because these are super easy to understand. But the most complex ones are the one in red and blue, which is called criterion validity and construct validity. Now, construct validity is the one that psychology researchers would use. very often when they develop a scale. Okay, so we'll just go through one by one for each validity. But before I start talking, I again want to pause and give you guys a moment to look at it and see what's face validity, what's content validity. You might feel a little confused between content validity and construct validity. That have a look, read it quickly, discuss with your friends, maybe again a pause for 2 minutes, and we will get started with validity. I will not ask you to run any of these, except maybe base and content validity when we do the pilot. But criterion validity and construct validity are very important for psychologists to understand what are those. And I'm waiting if you have any questions or clarifications. We will move on. Okay, shall we get started now? Okay, so I will not spend too much time. I'll go back and forth. Face validity is literally like a face validity. As I said, Jacqueline and I had a good discussion this morning. Jacqueline, do you know that I did almost a face validity check of your scale? So face validity is you are not using any statistical technique. You're just looking at and then can we use it? Does it measure what you want to measure? Right? So basically, the evidence for validity measure, it appears on the face value. So I did not statistically test it, but I told Jacqueline, this scale looks like it can measure whatever construction of that measure. How do you do that? You would read the items, you would look at the operational definition, and you would be like, So, like everything that I give you the feedback is a face validity feedback. Yes, looks good on face. Face validity is not very sophisticated, and it just gives you a judgment, right? So when we do pilot testing in next class, you're basically going to look at each other's scale, what's your operational definition, these are the items. So don't forget, when you bring your scale, please bring a scoring key. This is the construct, this is the operational definition, this is the Likert scale, and these are the items. When you give it to your friend is going to read, is this construct measured, can be measured by these items. You want feedback, and you're going to basically do inter-rater reliability. You're going to choose 4 friends to give you feedback, and you are going to say, is the feedback consistent? You're going to make decision based on consistency of their response, right? Content validity is based on comparing the content of the measure. For example, if you're measuring depression, you expect the items, the scale, the words, or the situation are measuring depression, right? So you will go a little bit further, one step ahead of face validity. So depression is defined by mood and by cognitive psychological symptoms. So if a measure of depression was content valid, it would include items for each domain. If your operational definition says cognitive and physiological, then for content validity, you're going to say how many items relate to cognition, how many relates to physiology.
That's your content validation. Actually, the reason in undergraduate education, when your professors say, bring a scale validated by other researchers, and you do not need to worry about all these details because they have made sure the scales are content and face valid.
Right? Okay. The red one and the blue one, the little complex one. So I need your attention. Now, remember here, criterion validity. Now, what's criterion validity is there are two types of criterion validity. Criteria means if I drink water, I will have a glowing skin. So what is this is the predictor variable. This is the criteria, right? The dependent variable. You have developed a scale. You work very hard. And you say, this scale is so powerful. It can predict your behavior about something. If you can prove that it is predicting, if you can prove that this water is making my skin glow, then this is really a valid water bottle, valid water inside. Okay? So, what researchers do, they measure something using your scale. They also measure another variable to see if this is able to predict this. For example, if I look at your Gaokao score, in this example, it's called SAT. SAT in the US is the exam that you take before you go to college. Now, none of you have graduated. Your final GPA is not known. Okay? I'm going to look at your Gaokao score and say, let's say your Gaokao score is on the scale of 500. I know it is not. It is 680, 780 something. So let's say it's 500. Ishan got 450 in her Gaokao score. Leslie got 480. Just random example. Somebody got 300, somebody got 200. I will look at your Gaokao score and I will predict your college GPA. Okay? And I'll say, your GPA is going to be 3.7. Let's say you're going to have 3.8. If in real time, their GPA is what was predicted, then what are we going to conclude? If my results, my prediction is very, remember regression analysis? If the regression is very strong, yes, R square, model, and all that variance explained, what would I conclude about the Gaokao test? That Gaokao is yes. Or if her Gaokao score was 80%, but her GPA is very low. Her Gaokao was 90%, but GPA is also 90. Her Gaokao was only 40%, but her GPA is very high. What will happen in that case? Gaokao is not able to predict GPA. Now, there is a problem. Either Gaokao was not doing its job, or the exams you took for GPA are not well. But a researcher will always choose predictive variable, which is very common in the literature. For example, your mood is going to predict your motivation. Very well established. Thousands of studies have established that if you have a good mood, your motivation is high. So you have a mood scale and you collect data on motivation only to find out the mood is not predicting motivation. It means what happened? Your criteria related validity could not be measured, right? So there are two types. One is concurrent, means immediate, right? Mood and motivation, and predictive means after a long time. So for example, I'd like to predict your GPA should be able to predict your professional success. After 5 years, if your GPA was 3.8, 3.9, you should be very successful in your profession.
If you're not successful in your profession, predictive validity will fail. My GPA was not doing a good job. You guys just got straight A's in class because you go after professors.
Professor, can I get more? Can I get more score? Can you give me one more point? Okay. So these are the examples. I'm not going to read from the slides, and you will have these slides for home, and then you can practice more, right?
This is the example. New anxiety scale gives the same results. So,
okay. So we were talking about concurrent validity. These are the examples, the Gaokao example I just gave. The final one and the most important one
has two forms, convergent and discrete. If you understand the meaning of these two terms, it's very easy to understand. Sometimes when we collect data and we have a scale, we would check these two kinds of reliability. Convergent means if all the items of the scale are related to each other. Divergent means you will mix two scales together and you will get the two items separately. You get that? You understand? No?
Okay. Remember the scale? The one that Ishan gave the answer? Here.
If I have to establish construct validity of this scale, what am I going to do? I'm going to look at, let's say, convergent validity. What's convergent validity? It's going to show me item number 1 and 2 and 3 and 3 will fall under one construct.
Yes, because they're all English related items. They are, what are we saying? They are converging together. They're coming as a family. These are family members, right?
And the English items would come like this.
So by doing this, I am saying they're all coming together. I am establishing
Convergent validity. By telling, look, all these items belong to this construct. This is a proof, right? If you agree on item number 1, 2, and 7, sorry, 1 to 7, right? 1, 2, 7. Oh, 1, 2, 4, and 7.
the correlation between 1, 2, 4, and 7 will be very high actually. And when you do a statistical analysis, they're all going to come together. I will show you in a minute. And all the English items will come together. But if you compare these two, this is called divergent validity. Okay, let me take you back to this figure which explains convergent validity so well. Look,
The construct is self-esteem. Yes. Item number 1, 2, 3, 4. Look at the correlation between them. Very high. 0.83, 0.8991. What does it say? They all are one family. This is an example of convergent validity. Okay? If one of the items was 0.43, means it does not belong to this category.
now you want, when you publish
Papers and you want to tell that if you develop a new scale, hey, my scale is doing the job it should do, it's supposed to do. Then what you do is you always measure another variable and then you show a proof that correlation between SE and SE2 is going to be very high. But if I see the correlation with LOC, it's going to be very weak. Yes? You are giving an evidence that this is measuring self-esteem, this is measuring locus of control. If you find item of one construct highly correlating with another construct, I'm sorry, there is something wrong. Your scale is not doing what it is supposed to do. So this is an example of convergent. And how can you check all of this? You can check all of this in AMOS, which we call structured equation modeling, right? Which some of you have not heard of. I highly recommend you to attend mentoring sessions, mentor group. They keep telling you, keep teaching you a little bit about AMOS, M plus, R. And these are not very difficult things, but you don't have to do in this class, but you may want to do later. Is that okay, everybody? Okay, great. A very good example. Some things could be reliable, but not valid. We are concluding our lecture, right? Weight scale. You wake up in the morning and it shows you, wow, I'm just 45. Next morning, 45. Next morning, 45. Next morning, 45. Yay, I lost 10 kilos. I'm 45 kilos. Why? The scale is reliable. Every morning it gives me the same result. You think it's valid? Maybe it has something broken inside. I actually weigh 56 kilos. It's showing me 45. Which means it can be reliable, but not valid. A scale can be reliable, but not valid. A scale can be valid, but not reliable. Valid means, yeah, you're not reliable. This is what you want. You want a scale that is reliable, but a quick overview. We had spoken about instruments. You are going to look for scales to measure the variables that you want in your experimental design. I would like to remind everybody, have a clear operational definition and have your items. Okay? The items should be nice and clear, should measure, should have high validity, should measure what you want to measure. How would you know that? We're going to run a small pilot next week. And with that pilot, you should be able to know a little bit about, is there any reliability, right? Will there be any reliability or validity concern when you collect your data in real experiments? Okay. So we talked about, because we don't want to make mistakes in data collection, this session we spoke about reliability and validity. Reliability is consistency of measurement. Validity is if the scale is measuring what it's supposed to. There are 4 types of reliability: castrate test, equivalent form, internal consistency, and inter-region reliability. Hope everyone understands that you are all going to use internal consistency, convex alpha for self-report measurement. Those who will do tasks might use inter-region reliability of the scores. There are 4 types of validities: base validity, content validity. Pretty easy. You can do it for yourself. You can have your friends help you. During pilot, you will do it. The other 2 validities, criterion and content validity, are little complex topics for undergraduates, but some students who are researching with professors are doing validity, convergent and divergent validity. It's not very difficult. If you know AMOS or M+, you can learn to run those validity tests. All right, so this is it. We have 5 minutes, and I'll keep quiet, and the floor is open for questions and answers, so you don't run after me. Questions can come from the unit, questions can come about your instrument. Ask. I intentionally gave you time, so we can have questions. Yes. Thank you very much. Excellent question. How would you like to collect your data? If you think your participants are going to be rendered in university, we assume they know English. But if you think you do not want any mistakes, like capstone people, I would always recommend to have your instrument back translated. Okay? You can do a mock back translation. Translate it by yourself or use AI. Give it to a friend to that. Okay? Very good question. So My answer is it's better to have 20 so that your friends are not making any mistake. Are taking more questions, please? It could be about today's class, it could be about your project. Are you sure? No questions? Nobody will run after me after the class? That's I have a question. Sure? I can wait. Okay. Yes. Three is minimum. If you have two, because they're looking at correlation. So reliability is, are they correlated? Right? So you cannot have less than like two, you can, but doesn't make sense. Three is minimum. And there are some scales that have three items. Yes. Excellent question. This is the reason I encourage all of you to ask questions in class. I forgot that. Jacqueline, remember we talked about that? Try and look for scales that are short. The big scales do a great job, but they're only useful when you're giving incentive to participants to read 20 items and respond. Your research is going to be even your capstone. You do not have a grant, you're not giving any participation incentive. It is highly likely if you have 50 items for one construct or 20 items, no one is going to read and give you good responses. So Zoe, your question was, can I pick a few? Well, run a quick research. Mostly, each scale has a shorter version. Most scales have their shorter version. Like Jacqueline this morning, agentic engagement. I told you there are 5 item scale. So look for a shorter version. That's number one. Number two, sometimes there are subscales. You can take subscales and try and see if there are any studies that have used only subscales, and there will be. I know. Did you check the paper that I have published? How many? 23. Okay. 23 is still okay, I guess, but definitely not. I mean, for me, the best ones are 7 to 8 items because when you run reliability, you're going to delete a few items to increase, because some items might not work exactly the way you expect them to work. So Zoe, it's your call. If you cannot find, go ahead with 20. Okay, now deleting the items is like this. You are you are claiming that you're baking a carrot cake. Okay? So a carrot cake, let's say there are 20 items, you decide to delete these 3 items. What if these 3 were mainly about carrots? Other was butter, sugar. That's my point. Like it's a metaphor that you have to make sure before you decide not to use certain items, is it going to affect the measurement of the construct? Because your job is to measure the construct. So is it going to affect the validity? So sometimes we are asked these questions. If you deleted those items, are they affecting the validity? But it's not just you. There are other researchers might be struggling. So you can do a little bit of research and find out what other people have been doing. Right? Like you saw, we used 21 and we published. Are there any other people who are using best numbers? So make decisions based on that. Yeah. Any other question? No questions, right? Nobody's running up to me with the laptop. No questions? Great. So I repeat, this weekend you guys have a lot to do. Okay. You're ready with the instrument sampling. We will do it next Thursday. And you have your instrument template. You have my comments for your introduction. Start working on it. Prepare for your quiz. Go through the slides and the textbook. And number 3 is don't forget to bring a scoring key. Definition, name of the construct, definition, Likert scale, scoring, and the items. Okay?
It's not, it will be nicer, as Joyce said, that if you bring it in Chinese language would be wonderful. Okay? So thank you, everyone, and I will see you all on Thursday.